the Virtual Reality Hand Redirection Toolkit. Hand redirection is a technique that grants a VR system control over the user's real hand movements during interaction in immersive virtual environments. Leveraging the perceptual phenomenon of visual dominance, hand redirection can decouple the user's real hand motion in physical space from the virtual hand motion in the virtual environment. As such, past research showed hand redirection to successfully improve proxy-based haptic feedback for VR through haptic retargeting. Moreover, hand redirection was shown to be a suitable approach to provide improved ergonomics of 3D user interaction. Recently, several studies contributed to our understanding of how hand redirection can be employed without users noticing the manipulation by studying perceptual detection thresholds. As a result of previous research efforts, a variety of different algorithms and approaches to hand redirection has been proposed. Despite the increasing interest by researchers and practitioners in the technique of hand redirection, so far, however, no unified framework existed to easily integrate hand redirection in existing VR applications or experiments. Until now. In this work, we present HART, the Virtual Reality Hand Redirection Toolkit, a first framework designed for VR projects in Unity and freely available as an open source project on GitHub. The toolkit comes as a Unity package and is accompanied by an online wiki and tutorials. The Unity package can easily be imported into existing VR projects and provides access to everything researchers and VR developers need to integrate hand redirection in their own experiments or applications. The scripts contained in the Unity package implement a modular class hierarchy. By this, users of the toolkit can easily implement their own custom redirection techniques and extend the framework. Alternatively, users can also use one of the many reference implementations of algorithms published by previous research. Each pre-implemented technique is represented by their own script and ships with the Unity package. The toolkit supports a variety of different hand redirection concepts and offers implementations of several previously published body warping techniques, which offset the user's virtual hand rendering from the tracked physical hand location during a reach as shown here in this video. Besides body warping, the toolkit also supports world warping techniques that maintain a one-to-one hand mapping and rely on translational or rotational manipulations of the virtual environment, injected, for example, during rotations of the user's head. Additionally, a support of 3D hand offset interpolation techniques enables users of the toolkit to map virtual geometries onto physical geometries that differ in shape, allowing users to receive haptic feedback while exploring virtual surfaces. The toolkit provides support for HTC Vive and Oculus Rift VR systems. Optionally, it also supports Leap Motion for hand tracking. As setting up a complete VR system for development or quick scene tests can be tedious, our toolkit additionally allows users to simulate hand movements with mouse and keyboard. In order to support the creation of scenes that employ hand redirection and to ease the workflow of setting up a hand redirection scene, the toolkit further offers a variety of visualization features. It highlights real-to-virtual object connections in the scene view and provides useful detection threshold indicators which highlight noticeable and unnoticeable redirections already during scene setup. Moreover, in the game view, users of the toolkit can see information about active redirections displayed in an info box, observe the scene through real and virtual lenses, and inspect hand trajectory renderings. All these functionalities are complemented by a basic logging system that collects redirection information for later analysis. We evaluated the Virtual Reality Hand Redirection Toolkit in a qualitative user study with 5 expert VR developers, and results indicate the toolkit to provide an overall positive user experience. The toolkit, the accompanying wiki, and tutorials can be accessed publicly on GitHub. Any contributions and extensions are very welcome, and we look forward to community feedback. Thank you.